This is Chapter 4, Section 5, Triangle Congruence. We have three different methods that we're going to be using: angle, side, angle, angle, side, and hypotenuse leg. Your objective is to apply these three postulates and theorems to solve problems and to prove triangles congruent. Go ahead and pause the video so that you can use your DOK words to write your essential question, and then go ahead and push play and come back, and we're going to go through this. The first thing that we're going to talk about is included side, which is similar to an included angle, where you have a side, and the angle in the middle is the included angle. Over here, we're talking about an included side, which means an angle, and then the side between the two that you're talking about is called your included side. First postulate, you needed to use that definition. So you have an angle, an included side, the next angle is congruent to an angle, the included side, the next angle. If that's the case, then I know that both triangles are congruent. Probably already saw that, but I'm trying to hide it from you anyways. It says that you need to determine if you can use angle, side, angle to prove that those two triangles are congruent, and then explain. So it looks like there's a bunch of markings on here. Really, the only markings that they gave you that are given are that these two lines are parallel. Because these two lines are parallel, I know that KLN is congruent to MNL, and that's because they're alternate interior angles. I also know that LN is congruent to NL because of the reflexive property. And I would like to say that KNL is congruent to MLN, but I don't know enough information to say that because I don't know if KN and LM are parallel. They look parallel, but they're not marked as parallel, so I can't make that assumption. So I don't have enough information to say that I can use angle, side, angle. The next theorem that we're going to talk about is going to be the angle, angle, side theorem. And this has to be in order. You have to talk about two consecutive angles and then the following side. Two consecutive angles and then the following side. The first angle that you talk about over here has to be the same as the first angle you talk about here. And then the two following are going to be the same measure, and then the next side has to be the same length. Oops. Let's see. Well, again, you probably already saw that, but I'm going to cover it from you anyways. We have to use angle, angle, side to prove the triangle is congruent. If you think you can do this on your own, go ahead and pause the video and give it a try, and then come back either when you get stuck or when you're done. First, we have our two pieces of given information. JL is a bisector of KLM, and then angle K is congruent to angle M. I have angle K here and angle N here. Those are marked, and then these are markings that I did myself. The reason why I marked these two congruent is because JL is the bisector, which means that KLM got cut in half and that both these halves are equal to each other. Because I'm using angle, angle, side, I want to develop a game plan. So I'm going to have K, L, and then this side, and then same thing over here, M, L, and then this side. So I'm going to start with this piece of given information. Angle K is congruent to angle M, and that was given. The next thing I need to state is the JL bisecting angle KLM, and the reason for that is because I need that piece of given information in order to talk about this next angle. Now that I know that it's the bisector, I can say that KLJ is congruent to MLJ because of the definition of a bisector. So I have an angle, and now I need the last side. So I can say that JL or LJ, whatever you want to say, LJ is congruent to itself because of the reflexive property. So now I have an angle stated, another angle, the third side. So angle, angle, side is what I'm going to use in order to prove that those two triangles are congruent to each other. The last theorem we're talking about is hypotenuse leg. I have a right triangle. I have the hypotenuse of both of those right triangles congruent to each other and one leg of those right triangles congruent to each other. So you have to make sure that it's a right triangle though, because if it's not a right triangle, then hypotenuse leg doesn't apply. This is the last example. You needed to determine if you can use hypotenuse leg congruence theorem to prove that they're congruent, and I decided that we can. And the reason for that is that they're both right triangles. So the first one was marked, I marked this one because that's the same line, perpendicular to the same line. So they're both right, and I know that the hypotenuses are congruent because these were marked. This was given information, it was already in the picture. And I know that they also have a leg congruent to each other because this segment right here is congruent to itself because of the reflexive property. So I have right triangles, a hypotenuse, and a leg congruent to each other, which means these triangles are congruent.